Alright, we are, get rid of that little bit there, we're working on Section 3, multiplying expressions. And if you recall, when you multiply variables, that means a letter, but it applies really in this case to numbers too, you add your exponents. If they have an exponent and you're multiplying them together, you are going to add your exponents. Okay? And why this came up, I don't know, but we can get rid of it. Alright, now the bases have to match. They have to both be, if they're a number, the base number has to be the same. If they're variables, the base letter has to be the same. And so, get rid of this down here. Keep popping things up. Okay, so in other words, if we multiply a squared times a to the 5th, if you wrote it out, that would be a, there's your a squared, right? And a to the 5th would be a times a times a times a times a. Well, you can write them all out. And you notice I have 5 a's here and 4, and all together then that's a to the 7th, if I was going to write it out multiplied. But the shortcut way to do that is to say that's the same, instead of writing all your, breaking it down and writing them all out, that's the same as a to the 2 plus 5. Okay, and I don't know why I'm getting such weird. Okay, so that's to a to the 2 plus 5. Say 5 and write 7, and that equals a to the 7th. So when we have something like this, you need to remember that the numbers you multiply just as they normally are, and then you just add the exponents on the variable. So 3 times 8 is 24. And the x, the variable on the x, when I get my answer, will be x cubed plus, times x to the 5th is x to the 3 plus 5. So my final answer is 24 times x to the 8th power. Here I have two sets of parentheses, several variables in the parentheses. Again, multiply your numbers just like you would multiply. So negative 5 times negative 3 is positive 15. Now, look at the base a. Here's a squared. And this is just an a, but the exponent on that a is 1 if there's nothing there. So it's a to the 2 plus 1 when I multiply them together. And our base b, we have 1 here, so it's 1 plus 2. If I'm going to write it out, which gives me the answer, I'll put it down here, 15a cubed, b cubed is my final answer. Okay? Now, we've got 3 parentheses, 3 things multiplied together. Again, do your numbers. If you want to pull them all out in front, you can. Really, it's just negative 3 times negative 4. Remember, it doesn't matter what order you multiply in. So you can put all your numbers out front. Then you can list your x's. We have x to the first and x to the first here, so that's 1 plus 1. And our y's, we have a 1 there and 3 there, so it's the exponents are 1 plus 3. Now, all of this is 12 times 5. It's going to be positive because there's 2 negatives we multiply together on the 3 and the 4. So that's 12 times 5. Okay, which is going, and then times x. And so the final answer is going to be 60 x squared y to the 4th. Okay. Now, multiplying these expressions, here we have to distribute. And I just tend to draw arrows, but you have to remember you're distributing everything there. And if you want to write out what it is, what you're doing is you're saying 5x squared times your 2x minus the 5x squared times the 3. Okay? And so you multiply that and you'll have 10x cubed, 10 times x to the 2 plus 1, which is x cubed. I have to put an x there though. minus 15 x squared. Okay. We cannot combine that any further because the variables, the exponents and their variables have to match. I can't add the coefficients in front of an x cubed and an x squared. And this is review for you, but hopefully you don't forget that. I could, if this was 10x squared minus 15x squared, I could combine them if the variables were identical with their exponents, but they're not. So I have to leave that as my final answer. Alright, let's distribute this next one. We have 2ab times 3a squared plus 2ab times 2b squared. And when we write that out, we have multiply our numbers again. You have 6a to the first times a squared is going to give me a cubed, a to the 1 plus 2 times b, plus 2 times 2 is 4. There's not another a, so it's just a, and it's b cubed. Well, even though we have a variable cubed and a variable to the first power in each of these elements, we can't combine them because in this one the a is cubed, the b is to the first power, and it's opposite that in this second term. A is to the first power, b is cubed. Again, the variables must be identical, all of them, before you can add your exponents. Alright, rather than we're going to write this out individually. Again, some of you won't have to do that, but we're going to go ahead and write them out all out individually. xy times x squared y minus xy times x cubed y squared. Okay, and so x to the first times x squared is x cubed, x to the 2 plus 1. Y times y is y squared minus x to the 4th, and it's easy to forget these single powers here. Don't forget to add those. 3 plus 1 is 4, and it's going to be y cubed. Okay, again, the variables don't match exactly, so you can't combine like terms. Your final answer stays just like that. Now, let's, again, we can write this out, or you can think of, now I've got to distribute this across 3 elements, the 5xy, just like I did. Well, we haven't done that yet. So we're going to distribute 5xy times 2x minus 5xy. We have to multiply it by the second element. And then minus again 5xy times 5. Okay, now let's multiply. This is going to be 10x squared y minus 5 times 3 is 15. Just looking at these elements that are multiplied, there's not another x, so it stays just an x. And then we have y squared, y times y. And minus 25xy. Go back and check to see if you have any like terms you can combine, and we don't, so we have to leave it just like this. Alright, now I hope you don't have any questions, and I hope you asked them in class, but we're about to go to the next page. So we're going to move on. Oop. Okay, we're going to move on here. Move down to the next page, where our instructions are to multiply trying to multiply two factors together. And this is much like this is really, I like to think of it as double distribution. If you have only two sets of binomials that you're multiplying, then you can go back to the old FOIL which stands for first, outside, inside, last, which is good for most everything until you get to something here where you've got to multiply. You've got a binomial and a trinomial that you're multiplying together. And then I think it's easier to think about distribution, double distribution. So let's first, on this one, we have to multiply the x. We have to distribute the x to both of them. So x times x, and that's your first terms you're multiplying together. If you're using the FOIL, it's x squared. Outside terms is x times positive 3, so that's plus 3x. Your inside terms, now you're going to distribute the negative 5 across. So you have minus 5x, and then minus 3. Now these terms both are x's. They're like terms, so we can simplify and combine those and get x squared minus 2x minus 3. And that's your final answer. And that's, I don't know where I got the 3. That should be a 15. So, you know, y'all know me. Okay, let's go back. Erase this one too. 5 times 3 is not 3, it's 15. So this should be a 15. Alright, looking at number 10, distribute your 2x, and so you have 2x times x is 2x squared minus 10x. Don't forget you have to multiply the 2x times the 5. Now we're going to distribute those 1 across, so those stay the same, plus x minus 5. When you multiply by 1, those numbers aren't really, they don't change value, but this then we can combine. So we end up with 2x squared minus 9x minus 5. That's our final answer. Okay. I'm going to do this without drawing arrows. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Your inside terms are positive 15x, and your last term is minus 25. And so what happens to this minus 15x and plus 15x is it cancels, it adds to be 0, so you end up with 9x squared minus 25. And hopefully you remember when you see this that this would factor if we were going the other way and we started with the 9x squared minus 25 and had to end up with these factors, that this is called a difference of squares. We can take the square root of each of these end terms, and there's a minus sign, thus the word difference, and that's how our factors look. That's the square root of each of the terms is our first and second term, and one of the factors is positive and one is negative. Now here we've got a number squared. We've got factors squared. It's easier, I think, to just go ahead and write it out. Whoops, except it's minus, not plus. 3x minus 2 times 3x minus 2. Now if you can remember how a perfect square is going to multiply, that's fine and good. Then you can be able to do that. But what you're going to notice, and I'll try to report that, and then when we get to 14 we'll try that strategy and then check ourselves. But let's go ahead and use this by writing it out longhand. We write it's 3x minus 2, all of that squared, so that means we have two identical factors multiplied together. So we have 9x squared, and we have minus 2x, minus 6x, and minus 6x again, and then plus 4. Okay? And so when we combine them, we end up with 9x squared minus 12x plus 4. Okay. Now if you'll notice that the first term is this first term squared, 9x squared. The last term is this negative 2 squared. And the middle term is twice the multiple of these two. So negative 2 times 3x is 6x. Multiply that by 2 because you get those two answers in the middle here that you combine to get the 12x. Now let's just practice that, and we're going to then check ourselves. So if we square, we're going to skip 13 for right now and go to 14. If we if we square 5x, we have 25x squared. And we have a positive 2 here at the end. Square that. That means my last term is going to be plus 4. And now it's a squared if it's a perfect square polynomial, so we're going to multiply these terms together. 5x times 2 is 10x. Double that. That means this middle term should be 20x. Okay, so if you can remember that pattern for these squared polynomials or binomials, that makes it very easy. You don't have to write it out. But let's, say you don't remember that. Then you just write it out, and let's double check ourselves. 5x plus 2 times 5x plus 2. And multiply using double distribution. We have 25x squared. Our middle terms are going to each be 10x plus 10x and then plus 4. And again, those two middle terms combine to give you this 20x. And so this answer is correct. Now look at 13. What do you recognize? We have identical, we have a 3a and a 3a as our first term. 2b and 2b, one is positive and one is negative. That looks just like 11. So that we think that would be a factorization of a difference of squares. So that means it doesn't have a middle term. So the first term is going to be 9a squared, and the second term is going to be minus 4b squared. It's the square of each of those terms with a minus sign in between. Okay, maybe you don't remember that. So FOIL it. You have 9a squared plus, outside is be plus 6ab. The middle terms are going to be minus 6ab. And the last term is minus 4b squared. And we notice, like we expected, that these middle terms would add to be 0 and go away. Alright, now these last two examples, you have a binomial multiplied by a trinomial. Well, you just do distribution. You have to multiply this x by each of these three elements, and then the 5 by each of these three elements, and then combine like terms. So, we have x squared, and then x times negative 5x is minus 5x, and this should be x cubed, not x squared. Minus 5x squared. And then plus 10x. And then multiplying the 5 all the way across, you have plus 5x squared minus 25x. And I'm going to write down here plus 50 because I ran out of room. Now notice what happens with our 5x squareds. They add to be 0, so they're going to go away. There's two x terms here. There's a 10x and a negative 25x. So we bring down the x cubed. 10x and negative 25x is negative 15x. And there's not another constant term, so we just bring the plus 50. Now many times what I like to do, instead of having them all in a long row like that, is try to line up like terms and then just add them together. And so let me show you how that would look. We have 2y times 4y squared is 8y cubed. Now we're going to multiply 2y by the middle term, and that will give us plus 12y. And then the 2y times the 9 is plus 8. This should be y squared, excuse me. And then we have plus 18y. Okay. Then I'm going to say the negative 3. So negative 3 times 4y squared is negative 12y squared. Well, here's my y squared term, so I'm going to write that underneath there. And then negative 3 times 6y is minus 18y. And then negative 3 times positive 9 is minus 27. And then when we add them together, we notice that these will add to be 0. These add to be 0. And so we have 8y cubed minus 27. And this is a difference of cubes factorization. And we learned that in Algebra 2. And so I don't know if you remember, because a lot of you did have trouble with this, but the cube root of 8y cubed is equal to 2y. And the cube root of 27 is equal to 3. And so if you remember, when we did this difference of cubes factorization, we labeled this A and this B, and this was a generic formula for how you would factor a difference of cubes. And I'm just reminding you of some things we've done already. So you remember you have A minus B, and you look up here, there's your 2y minus 3, times A squared. 2y squared is 4y squared, plus AB, A times B, which is 2y times 3, or 6y, and then plus B squared. And that was the factorization for a difference of cubes, if you were going to factor a difference of cubes. And these are going to come up again. And you struggled with them last year, but it's time to learn them. Here, in this practice, in this particular assignment, you're not factoring, you're multiplying, but factoring will come back. So as we hit these, I'm trying to kind of remind you. All right, that's the lesson. That's the end of the 1-3 review.